G'day viewers. Well, believe it or not, this thing was going straight in the scrap metal bin. The indoor unit and everything. It's been out in the weather for about 3 weeks, so it's not too badly damaged. They did renovations up in the office at work, and they put a new one up, a bigger unit I think. They just set this thing outside, and we did some maintenance guys were all there. I was looking for it all. He goes, oh, yeah, piss this off. I go, hang on, I'll have it. I go, alright. Yeah, because they've got things, they're going through all the stuff like motors and all the bits and pieces that they're going to throw in the bin. So I should be able to get some other scores as well. So this is one of the stuff that would have ended, one of the many things that would have ended up going in the scrap metal bin. It's being properly sealed. The pipes all been properly sealed. It's a whole complete bloody unit. I'm just going to throw it in the bin. Made in Korea, genuine carrier. It's a good unit too. No additional refrigerant charge required up to 15 metre tube length. Model number 53P250H. 10.8 amps, 10.6 is a rating current, so I could, in theory, run it off a standard 10 amp plug, but I can't because the actual continuous current is 16.5 amps, so it's going to be in a 15 amp socket. Ooh. I better not do that, I'm rubbing it off. R22, 1,450 grams. Yeah, it's an older unit, R22, there's no date code. It'll be at least, well, the plug top of that indoor unit is not insulated. So this is at least, said it's not insulated, so it'll be at least a mid-90s. Mid-1990s, I think. Let's see. $10.4 cooling, 10.6 heating, 2.3 kilowatt, 200 BTU per hour. It's an okay size unit too. And I'm going to pull it all apart, clean all this unit up, get the dirt and rain stuff out of it and clean it right down. It's not even that, well it is old, but not that old. Mid-90s as I said. The wiring is all intact. Just the insulation's a bit, here I damaged it. I have to fix that. I've got a signal wire is all intact. It goes to the indoor unit that tells the this unit to turn on and off when you press the buttons on the remote. You've got the valves here, chargers from back in here to charge it with. Chargers from in there to suck the refrigerant in. Yeah, I'm going to have to replace all that. This has been sun damaged. No, I think this would have been on the roof. Most likely would have been installed on top of the roof. So 2 stories up. It's all pretty clean, not too badly dirty, so I'm going to pull it apart and clean it. Nice old R22 refrigerant unit. We have got a can of freeze spray, HFC 134A. But yeah, don't have to check the compatibility with that. If it's compatible, I could just stick that in there to charge it with a can of freeze spray, which is quite easily available. The air dusters are now butane, so they're not refrigerant based anymore. There's actual valves behind here. You screw the ins and outs out. There's like a valve in here that closes all this off completely. In here, under these caps. Usually only a vacuum pump for air purging. Also the fridge compressor comes in handy, but as long as the oil, all it really matters, as long as the oil inside the compressor is actually compatible with the HFC 134A gas. That's the only thing you're going to really worry about. Anyway, let's get this thing out so I can clean it. I'm going to pull it all the top off and just check it all and aim up the compressor just for, it'll be okay, it's got to be. I also don't remove it. But yeah, let's just get it out of here and give it a good clean. Alright, there's the inside of it. Daewoo fan motor. Family protected. Equipment manufacturers. Daewoo electronic motor industry made in Korea. A Daewoo motor. The more modern ones now are inverter and DC. If you actually take one of these fan motors out of one of those, like that one there for example, they actually all run on DC inverter technology. And the beauty about that is you can run these fans like a generator because they've got permanent magnets in them. You spin them up and it can generate some power. So we've got 4 speeds here, we've got 4 sets. So we've got 2 to start all the run capacitor wires going in there. Good capacity is for your ZVS. Oh, young. 5 microfarad, 400 volts AC. Actually, I remember seeing these on eBay. I was going to buy stuff for my ZVS. So that's for your motor, your fan motor. There's a resistor. That's part of the goes in here. Part of the soft starting, I think. It goes in the starting kit for the compressor. 5-watt resistor. It's been cooked. I like how they sealed it like that. They sealed it so it doesn't get corroded or damaged from the elements. It's a good idea. 40 microfarad, 370 volt AC start capacitor for the compressor. All these newer ones don't have all this. The DC ones have an inverter board here. It's like a VFD that runs the compressor and the fan motor. That's why it sounds so funny. And they regulate the speed of the motor in the compressor as well. So they're kicking it at flat neck all the time. Part of it makes the newer ones more efficient. So you can charge it from there. The coils look pretty damn good. Been nice to hook this up and actually install it in my man cave. I know 8.50 did. Here I got it all set up and running properly. Must have had a charge or something in it, enough gas in it to run properly. The one I've actually decommissioned it to just crimp the pipes really hard so they seal. They crimp them and flatten them with a tool that seals them, and then they cut them. So there's no air in the system either. There's still refrigerant in there, but half of it's in there, half of it's in here, and half of it's in the bloody line set. So 1.4 kilograms of R22. A can of freeze spray is about $17. That's about 400 grams. So I need at least 4 of those if I wanted to top this thing up all the way. Yeah, this is an old AC unit. The one's an AC, not DC inverter, like the newer ones are. So it's not as efficient, but still pretty damn well worth keeping. They are a lot last longer. There's no inverters that bugger up. See, we've got the active. I might keep those separate. Actually, take those off. Live, neutral, and you got your 3 connections in here: red, white, and red. Which is our power supply, live, neutral. Note, power supply from indoor or outdoor. So you've got your 3 control signal wires from the indoor unit. And all wires up under here. There's a reset button under there of some sort. There's more metal vapor lights too. I should be able to get a hold of as well. I told the guys I just want the lenses off them so they can replace them off the ones in the factory as they get hit with forklift masks and stuff. So they'll still be alright to me without the lenses. Hopefully they won't throw those lights out. I asked them about them. They said they'll hold on to them. And I left them a note on some other stuff as well. I said I'll leave them a note. The stuff that I want. I may get some more motors too. Yeah, I have to pull this apart and clean it. There's a control board in there. And I think those are for the remote or something. I can't really remember. I have got the remote to this too. Live, neutral, active inputs, and they go to our unit. It's pretty easy to wire up. Not rocket science. 1, 2 and 3. So you got the main live and neutral from the power plug go straight to your compressor, and your 1, 2 and 3 go your control wires for your fan and everything. And a signal wire. There's a little tiny signal wire in here somewhere. Which is that little one? This one. Yeah, look like a signal wire because they haven't actually got three actual. Instead of using an actual proper three-phase cable, it's cheaper to use one of these, a single live TPS, then bundle it with another normal TPS cable. There's a wiring schematic. Thermistor, the resistor goes across the thermistor. Soft start kit. So it's a soft starter kit, stops the compressor from dimming the lights every time it starts with high torque. The soft start just makes it ramp up and then run to full speed without tripping breakers or dimming your lights. That's basically what the soft start does. So I have to pull all these screws off, pull this plastic off completely and wash it all with a garden hose and clean it. I'm pretty sure this thing's fine, there's nothing wrong with it, they just wanted to upgrade. For a nearly renovated office, this thing probably does look a little bit old anyway. So this is broken up here. One of the things is missing off there. One of the reasons why I got rid of it. Just cosmetic things like that. Yeah, well, let's clear this thing up. Got some fair bit of cleaning to do. What's wrong? Hey, Whiskers. What's? You're happy. That's good, cat. You be happy. Alright. I've got some cleaning to do. First, I drag out the multimeter and do some compressor tests. So I really, to get the actual to the compressor itself, I'm gonna have to pull this front plate off. That slides off. So this front part comes off here. And this outer shell slides off to do that. That'd be the easy way to do it. I can get to the compressor barely and test it at the terminal block and arm it up, make sure she's okay. I'll even get the mega meter out to confirm it's still alright. Yeah. Just cosmetic things is one of the reasons why I got rid of it. I wanted to upgrade to a new one. What is that? Cycle reversing valve. Flow goes that way. Got a splitter in there. It's quite cold. Interesting. Yeah. Hasn't been going, but could possibly still be a refrigerant in there. I reckon there is. There's got to be. Because if they just kinked it shut like that and it's left it. The valves are in here. So you pull these off. The spanner goes in there to close them down. Hopefully they had the suction open and turn the pressure off. Not really the best way you can do it, but if they did that and turn the high pressure off, shut it off here, and sucked it and pulled the whole thing under a vacuum, then they turn this off and all the refrigerants all in here instead of in here and in the piping. It's not the best way that they can actually do that. Normally, when you decommission it, they have to recover all the refrigerant out of it from here. They just suck it all out into a tank. It's actually pretty clean in here. Can't see the brand label on the compressor. It's on the bloody other side. There'd be a Daewoo compressor or some Fuji or Thai made or something like that, or SCI. I mean, SCI CM compressor. International, which is what Fujitsu actually, or later Fujitsu Mitsubishi's use. I don't damage it too much, because I reckon this is going to work again. I can't even get to the top of the compressor to get to the terminal block so I can test it. That's what I want to do. I want to test it and make sure it's electrically good. Yeah, up there, see? Even if the unit's stuffed, I can get a good air compressor out of it. Yeah, be careful here, don't damage anything. There we go. Now I could own the compressor through these wires here. The red, white and the blue. Going off the red, so I've got a red, white and a black actually. I could try it from there. I'll probably get a bad reading though because it's going to go through everything else before it goes to the compressor. The easy just to pull that terminal cover off and do it, but it's pretty tight in there. Let's see. There's a label down there. I can barely read it. I can barely read the label on that compressor. Yeah, I can't read it. It's got a heater wrapped around. This wire is going to a heater. There's a heating cable on there that keeps the oil warm so it doesn't get too cold and start to get too solidify and freeze. So they keep the oil warm so it doesn't freeze up under the compressor. It's a crankcase heater. Vanco brand, decent quality refrigerant gear. Yeah, it's one of the better units. They don't make them this good anymore. These are pretty disposable now. The date code is not filled out. It's definitely early 2000s. Furnace, Mexico made relay. 20 amp, 25 amps. 240 volt 50 hertz coil, mains coil. Alright. I'm gonna just aim it through the wires instead. A bit too squishy to get down in there. I'm trying to do this the redneck method. Now I always used to do it without the tripod. So I lay in the multimeter on its side, like this, and face the camera at it. I've actually got the right range on this time. I had the range set on wrong. Should work properly now. Alright. Let's see, I've got the white wire. Between a big chunky white wire and the black. That's our run. 3.3 ohms now between the run and the start. This big red wire going off the starting board. 1.1 ohms between the black, common and the start. Now from run to start. .8 ohms. That looks pretty good. Looks about normal. Do a couple more tests. Just did a run winding without the start wire. I think I did that the first time actually. Yeah, I did too. That was the first reading I got between the common and the run. Start to run. 4.4 ohms. Yeah. That doesn't look too bad at all. Looks like it's in good shape. I'll probably disconnect that capacitor if I'm going to use a mega meter because I'm going to put 1000 volts through that. And A, could damage it because it's only rated for 350 volts. And B, I'll charge it up and give myself a big kick up the arse. So, yeah. So this is actually a start for your compressor. So the best way to tell that, obviously, you get a starting board on there. It's a soft starter. So it looks like we've got a rectifier. Okay, so that capacitor steps it. Looks like it steps it down. Interesting. It's got some control wires on there. Neutral and active. Goes to this transformer. Steps it down. These are rated for 35 volts. So somewhere around 35 volts. You've got those MOVs on there. NTC 20026 MS32. Interesting, this is a low voltage to start it. On relay. 12 volt DC relay. Interesting. This is around about 12 volts or so. So we've got 12 volts on for the relay. Yeah, be 12 volts on that relay. Interesting method to start the compressor up there. A little signal like that. Interesting. That just goes straight to the compressor, the start winding. And the blue wires go to that relay. And jumps through to our mains neutral. Through the relay, it's shorted actually. Bridged straight to that board. To start the compressor. Interesting, it's like a little 12 volt power supply to start a 240 volt compressor. Interesting concept. Anyway, the next challenge is as well put this, hook the lines back up to it. And the copper piping on this, I'm going to have to make sure these are off, re-flare them and join them on again. So So make sure these are off first before we remove these. And these have to be cleared inside, no dust, nothing can get in. So if I reflare these to the original pipes that are on it, make sure those are still turned off. I have to pump them under a vacuum because I'm going to cut the pipes and air's going to get in, even though I'm not pushing air through it. The atmosphere will get in, so I'm going to have to suck the lines with a vacuum. Once they're all on here and they're still off, pump the lines under a vacuum and do the same process with this. Although this, I don't think you can isolate this thing, so this has to be, the lines have to be hooked up to this thing. The line set's going to have to be hooked up to this, and suck this under a vacuum as well. Well, one's still connected, and suck one under a vacuum, and somehow, yeah, there's a way to do it. Basically, make sure it's all has to be intact, all hooked up, and you put the whole thing under this line set under a vacuum, and at the same time, while you take the thing off it, you let suck an air back into the system. Here we've got a big muffler on the compressor, like an accumulator, and the filter dryer. No rattles. Usually they rattle, they're desiccated inside them. Yeah, well, worst case scenario, air compressor, but it's kind of too good for that, but anyway. Nice long video for you. I'll put it back together and give it a good hose out. Anyway, that'll be enough for now. Thanks for watching.